We are talking about triangles today, and I want you to notice the phrase I've got written on here. It says triangles are classified two ways. You can classify triangles by sides, or you can classify triangles by angles. This first group we're going to look at, these are all classified by sides, and it's talking about their side lengths. We've got three names here. We've got scalene, isosceles, and equilateral. Now, let's look just a minute. Now, if you'll notice, all of these have these little dash marks. These marks are called tick marks. And tick marks are sort of like it's a code to let us know what side matches that side. For instance, I see 3 tick marks. You don't see 3 tick marks over here. I've got 1 tick mark and 2 tick marks. They all have a different number of tick marks. That means each side length is different. Each side has a different length, and that's scalene. I always think of scalene, like Cagaline, Magaline, oh, Spigawaggling. Scalene was her name. She had 2 hairs on her head. One was black, the other one red. Oh, Cagaline, Magaline, oh, Spigawaggling. Scalene was her name. She's just a strange person or being, but all of her side lengths are different. That's scalene. And then we go over to isosceles. And isosceles, notice it's got 1 tick mark, 1 tick mark. That means that these sides are equal. So 2 sides have equal lengths. That's isosceles. Now you might see the isosceles written up, drawn upside down. See, that would still be an isosceles as long as 2 sides are equal. Here I can do it like this, sideways. Not really straight, but anyway, that would also be isosceles. When I think of isosceles, I think of Hercules. Think of Hercules, each side, he's got his muscles. So isosceles. And then we come over to equilateral. Equilateral is perfect in every way. All sides have equal lengths. See, 1 tick mark, 1 and 1. I'm telling you, all of those sides are exactly the same. So we've got scalene, isosceles, and equilateral. That's talking about the sides. Now, down below, we're talking about the angles. That's where the lines meet to form an angle. Now, there are 3 ways we can classify a triangle. It can be acute, it can be right, and it can be obtuse. Let's start first with this acute triangle. An acute triangle has all angles less than 90 degrees. That means every angle is acute. That angle's acute. This angle is acute. And this angle is acute. It has 3 acute angles. Now, let me let you in on a little trick or a little secret. Every triangle has at least 2 acute angles. Let me repeat that. Every triangle has at least 2 acute angles. The third angle will give it its name. So if I say acute, acute, whatever the third angle is tells me what kind of triangle it is. Look at this one. Let me find the acute angles. There's acute. Here's acute. And there's my third angle. And what is that? It's not an acute angle. It is a right angle. So that names the triangle. This is a right triangle because it has 1 right angle. Remember, every triangle will have 2 acute angles. The third angle will give it its name. Look at obtuse. There's acute. There's acute. And then here's this one. It is obtuse. Remember, the angle that's not acute is the name of it. If they're all acute, then it is an acute triangle. But the one angle that's not acute is the name of it. The other two will be acute. See, this will have one right angle. This will have one obtuse angle. So after you work with it a little bit, it gets a little easier. So we're going to continue practicing a little. All right, it says classify each triangle, right? Isosceles, scalene, or equilateral. Now, if you look back on the front, when we use those names, we're looking at the sides. So let's look at the sides. Look at number 3. The lengths are 2, 5, and 4 feet. Notice how none of the lengths are the same. So that is scalene. Look at number 4. Look at the lengths. They're all equal. So that is equilateral. Number 5. 2 are the same and 1 is different. And remember, when 2 are the same, it's isosceles, like Hercules. And number 6, all of the lengths are different. So that is scalene. Now, I'll use a different color pen this time. Classify each triangle, right acute, right, or obtuse. In this case, we're looking at the angles, not the sides. So I'm going to label the angles. Here's acute, acute, and acute. If they're all acute, then that is an acute triangle. Let's label these angles. Acute, this is obtuse, and this is acute. Remember, if there's an angle that's not acute, that's the name of it. So this is an obtuse. Acute, acute, and this is a right angle. So this would be a right triangle. Number 10, acute, acute, obtuse. So we just named it. This is an obtuse triangle. Look at 11, acute, acute, right. So this is a right triangle. Pause it and try these on your own and then play it and see if you were correct. Acute, acute, obtuse. So this would be obtuse. Acute, acute, acute. So that would be an acute triangle. Now this says classify each triangle, right? Isosceles, scalene, or equilateral. That means we're looking at the sides again. I would challenge you to pause this and see how well you do on your own. We're looking at the side lengths. You can label it with an I, an S, or an E, and then play it and see how well you did. Okay, number 14. 2 side lengths are the same, so we know that is isosceles. Number 15, all side lengths are the same, so that they're all equal, so that's equilateral. Number 16, all side lengths are different, so that is scalene. Cagling, magling, ospiegel, scalene was her name. Look at 17, side lengths, 2, 5, and 4, they're all different lengths, so that is scalene. Okay, how well did you do? All right, the next grouping says to classify each triangle, right acute, right, or obtuse. So let's look. We're looking at the angles. So let me label all the angles. Acute, acute, and right. So this is a right triangle. Number 18 is a right triangle. And I challenge you again, pause the video and see how well you can do on your own. Number 19, acute, acute, acute. So 19 is acute. 20, acute, acute, obtuse. So number 20 is an obtuse. 21, acute, acute, right. So 21 is a right triangle. Remember, if you're looking at the angles, the angle that's not acute is the name of it. If they're all acute, then it's an acute triangle. Now, down at the bottom, it says, find the unknown angle measure. Now, here's something that maybe you haven't heard of before. But if you were to measure all of the angles and add them all together, a triangle, all of the angles would equal 180 degrees. So when I look at these, I know that I've got to say 95 plus 25 plus another number would have to equal 180 degrees. Now let me explain to you how we know that 180. Think about a square. A square, we know, has 4 90-degree angles, right? What is 90 times 4? It would be 360 degrees, right? So that's what a square would measure. So let's come over here and draw this square again. And this time I'll draw a diagonal. And so see, if a whole square is 360, when I cut it in half, this side would be 180 degrees, and this side would be 180 degrees. And notice it's a triangle. And if you think about it, this angle would measure 90 degrees. This would be half of 90, so this would be 45 degrees. And this will be 45 degrees. If I add those three numbers, I get 180 degrees. So that is what you would get if you just measured the angles of this one triangle. So let's look and see what the angles would be over here. Look at 22. I've got to add what I've got. I've got 95 plus 25. That's 10. That's 120, right? I know it's got to have 180 in all. So if I say 180 minus 120, that gives me 60 degrees. So the missing angle is 60 degrees. That's how you'll do all of these. You'll add up what you get and subtract the answer from 180. And whatever's left is what the missing angle should be. Let's try one more. We'll come down and do 25. We've got 35 degrees, 110 degrees. If I add those, that's 145, right? So now I'm going to have to take 180 minus 145. So that's 5. That leaves me 35 degrees. So that means the mystery angle is 35 degrees. So I'm going to skip these two for time's sake, but you can come back and do these on your own. But that's how we do it. We add up all the angles and take away from the total that we know it should be. All right, let's look at the next page. All right, it says, which best describes this triangle? Now, we've got acute, obtuse, right, and then equilateral. These words right here, acute, obtuse, and right, these are going to look at the angles. Equilateral will look at the sides. And I can tell you immediately that all of these sides are not equal. So I am ruling out an equilateral. So now I've got to look at the angles. And remember, the best way to name it by angles is to go ahead and name all the angles. Acute, acute, obtuse. So that makes this triangle an obtuse. See that? All right, it says, how can you classify this triangle? Well, they're calling it isosceles right, isosceles obtuse, scalene acute, and scalene right. Well, immediately I notice the degree right here is 90 degrees. That means this is a right triangle because this will be acute, acute, and right. When you see the degrees, they're not measuring them. The sides, this is the measure of the angle. So I know I want this one or this one. So I can go ahead and rule out B and C. So the angle, it is, if I look at it by angle, it is a right triangle, but is it an isosceles right or scalene right? Now, what you could do is sometimes you can take a piece of paper and measure. If this was isosceles right, that means that two sides would be equal. Let's see if that's the case. I'll measure it using my paper from that corner to here, and let me see how that works. So that does it. That side is definitely longer than that side. So let me try this. And look at that. They're not the same. So it can't be, no two sides were the same. So it can't be isosceles right. So it's got to be scalene right because all of the sides were a different length. Number 3, what is the least number of acute angles a triangle can have? Well, we know a triangle can only have 3 angles. And it can be all 3 acute. But we know a triangle will have at least 2 acute angles. Because remember, that third angle could be, just like in this case, had 2 acutes, but that third angle could be something else. But we know it will at least have 2 acute angles. So I'm going to go with C. All right, it says Colin must go from his home to school and then to the baseball field and then back home. The path he will travel today is shown below. Here's his path. Go from home to school to the baseball field, then back home. Which best describes the triangle formed by Colin's path? I'm going to look at the angles first. Let me go ahead and name my angles. Acute, acute, obtuse. So I know this is an obtuse triangle. Look at the angles. The only one calling it obtuse is A. It's not a right triangle, so I can mark out B and D, and it's not acute because all 3 angles aren't acute. So it would have to be a scalene obtuse. Remember, scalene means all of the sides are different lengths, and you can pretty much tell that's the case with this one. So A is right. And I encourage you to pause this and answer it on your own and then play it to check yourself. Which triangle is a regular polygon? Remember, a regular polygon is going to have equal sides and equal angles. And the only one of these that would have equal sides and every angle equal the same would be the old equilateral triangle. Number 6. Which type of triangle has 1 obtuse and 2 acute angles? Remember, it can only have 3 angles. When you name them, you got acute, acute, and 1 obtuse. Remember, whatever the odd angle is that's not acute, that's the name of it. So that is obtuse. All right, we're almost done. It says, how can you classify this triangle? Well, let's do angles first. That's so easy. Acute, acute, acute. So we know it's acute. So it's going to either be A, which is scalene acute, Or C, which is isosceles acute. I don't want B and I don't want D. So looking at that, scalene acute, isosceles acute. Well, scalene means all the sides are different. But if I look, this side is the same length as that side. So I'm going to go with isosceles because two of the sides are the same length. Number 8. What is the maximum number of right angles a triangle can have? Well, we know that every triangle has 2 acute angles, and a triangle can only have 3 angles in all. So that means that it can only have 1 right angle if it has a right angle. So the answer would be B. Now, I'm going to go ahead and stop here. If you have any questions about triangles, let me know and I'll be glad to help. Thanks for watching.